Hello, good morning to all the students. Okay, are you here? Okay, can listen me or not? Okay, here got 14 student is watching now. I don't know you still got MX class or what. Okay, we still continue the lesson, huh? Okay, good morning, Lisha. Okay, can listen, huh? Okay, so from here, I want to make sure Jia Yao here or not. Ho Jia Yao. Okay. Ho Jia Yao, morning. Okay, can you give me the response? Okay, Yiru, morning. Lisha, morning. Okay, so we go to continue the 4.3 lah. Today I want to complete the transformer. And also I already upload the exercise for you. That means later X class we need to discuss. Okay, Jaya, morning, eh? Okay, so we start today lesson 4.3. Okay, then it's still transformer, but this one's a series number 2 lah. So series number 2, we need to complete it. Okay, let's see about the transformer. Before that, we learn about step up and also the step down, is it? So we got number 4 and number 5 part is about the leakage. Okay, leakage of the transformer when they're changing the flux. So this one leakage we need to overcome. Okay, overcome this one problem. Then after that, so that's why the efficiency we cannot get 100%. Okay, ideal transformer is a one of the perfect transformer, but we not every time to get the perfect transformer, because when we do something process, they sure got energy loss. So today we learn about that, how to overcome this one energy loss. Okay, we go through. Okay, so this one is energy losses in a transformer. So you can see about the transformer, they got number of turn. Okay, then lah when you're using the wiring. Okay, number of turn, if you're increasing means the length you make it to increase it. So that means length increase, understood, resistance height. So resistance height is one of the thing to lose the energy. Okay, another thing you can see why the transformer they create by layer. Okay, they cannot using one whole thick soft iron. Why they want to create by layer? This one is a later we go to discuss. Okay, how to reduce the energy loss. Okay, now we're going to see the energy loss is due to what? Okay, first one, the working principle of the transformer, such as flow current in the copper coil, the chain of the magnetic field, and also electromagnetic induction. Okay, this one is a working. Okay, we're using the changing magnetic field. After that, we also using the principle electromagnetic induction. Okay, next, this causes loss of the heat energy. Okay, when they're just changing the flux, actually they lost the heat energy and the transformer is unable to operate at the optimum level. So from here, the output power is always less than the input power. So that's why when we do the calculation for efficiency, we cannot get 100%. Okay, so normally the energy that lost by the transformer, there is a heat energy. Okay, then we go through to the effect and also the way how to reduce the energy loss from the transformer. Okay, the first part, when I want to discuss about the effect and the way, normally this question they come out is an essay question. Okay, maybe they just let you to choose PQRS different of the transformer. Then they ask you which one modification you need to use to reduce the energy loss. So this one is one of the tips for you to answer the essay question if they come out for transformer. Okay, first one, the causes of the energy loss, there's a resistance of the coil. Then everybody know because they're using the number of turn. More number of turn, you can produce more voltage. But the number of turn, they can reduce the efficiency because your energy loss due to long wire, high resistance. So from here we see the effect. The primary and the secondary coil, they consist of the wire and also very long. So when the current just pass through the coil, they have the resistance and also hitting the wire occur. Okay, so from here, the heating of the wire, they cause about the heat energy to be released to the surroundings. Okay, so from here, we need to overcome. So before that, we learned already. Length is a directly proportional with the resistance. So that means you want inversely proportional means now length we cannot control. We cannot say you're using shorter, no, because you want to increase the voltage. So the length, we just stop it. We don't touching about the length. So we're touching about the thickness. Okay, thickness you can control. So way to overcome the problem, we're using the thicker copper wire. Okay, normally we choose the copper wire compared to the aluminium because copper both also is a good conductor. Copper is a more low cost compared to aluminium lah. Okay, because transformer, if you want to using the more of the wire, if you're using high cost, that's a more expensive. Okay, normally we're using the copper wire and also thicker copper wire because thicker can reduce the resistance in the coil. Okay, so this one is a way how to go to reduce. Okay, don't repeat the explanations. Don't every time to say reduce energy loss, reduce energy loss. Okay, I know everyone also reduce energy loss, but you got specific a bit. Okay, for the resistance, we can mention thicker copper wire reduce resistance. Okay, so we go to second causes. Okay, second causes, the name we call it as a eddy current. Okay, now we see what means of eddy current. Okay, you can see the diagram. Okay, this one is a full. That means just now I mentioned for you the transformer. They're using the whole block of the soft iron. Okay, this one is layer by layer. Okay, why they want to using the layer by layer compared to the whole block? Okay, this one is talking about eddy current. Okay, eddy current they will produce when changing the magnetic field, induce eddy current in the iron core. When you just changing magnetic field, they will produce a eddy current. This one eddy current, they will heat up iron core. They will heat up the whole iron core. So that means the hot iron core release heat energy to the surrounding. Now you can see if I'm using the whole block, that means eddy current is more and more because they want to heat up the whole block. You also need to changing many flux for the whole block. If I using layer by layer, actually you just changing many flux by one layer only. Okay, the behind the layer, maybe they never using soft iron core. Okay, they just want to make the first plate is a soft iron core. They can changes magnetic flux perfectly. Then the behind one, they can using the insulator. So that means like this, they can reduce the eddy current to loss to the surroundings. So from here, they say how to reduce this one energy loss. So we using laminated, okay? Laminated soft iron that consists thin iron sheet. So that means we never using the whole block iron. If you're using whole block iron, that means when they just magnify, they will induce more eddy current, then changes become the heat. Okay, if I'm using layer, that means the iron sheet by using the thin layer and layer, so that means they can reduce the changing of the magnetic flux to produce the eddy current. Okay, but the function still the same. They still can magnetize the soft iron. Just they're changing the behind layer because behind layer we know no need to use one. Important is in front that part. So that means they're changing become thin layer sheet glued together with the insulation group. Then we make it become thicker. So this one is a one of the way how to reduce the eddy current. So you no need to talk so much. You just say use the laminated iron core. They understood already. So use the laminated iron core. I mean you can reduce the eddy current just like this. No need to explain about longer. Okay, number three. Not yet. We go and see the diagram. Okay, so this one we call it as a whole block lah. I told you there's a whole block. So eddy current they need to run by the whole block when they just magnetize. Okay, so you can see if I'm using the layer, so that means the eddy current just go plate by plate. So plate by plate. After that, they're using the thin soft iron. That means there's no need to waste so many current to produce a changing magnetic flux. So that means this one situation, the layer part, they can reduce the eddy current. Okay, so this one current we call Eddy current lah. The Eddy current, they just when they how they produce when they're changing magnetic flux. When they just produce, they produce what? They produce heat. Okay, so this one we call it as a Eddy current in the core. Okay, then we go to number 3. Number 3, the causes of energy loss. His hysteresis. Okay, we call it hysteresis. What means of hysteresis? Okay, hysteresis means the iron core, the center one we call iron core, is it? Iron core is magnetized and demagnetized. Remember, I told you they become temporary magnet. So when the current just go, they become magnet lah. When the current just release, they no more magnet. So we call it the iron core. They will magnetize and also demagnetize. They will continuously by changing the magnetic field. So the energy supply for the magnetization is not fully recovered during demagnetization. So that means when it just demagnetize, actually inside they still got the heat. They cannot straightforward stop all the thing. Okay, they still got supply a little bit magnet inside there. So the difference in the energy is transferred to the iron core to heat up. So that means during the magnetize and demagnetize, they're also using energy. Okay, so that means how we make it better when they magnetize and demagnetize. So we're using soft iron core. Remember, don't using steel. Okay, steel, although they are a good conductor, but when they become temporary magnet, the steel, they will always become permanent magnet. Okay, that means they're very hard to demagnetize. So we want the temporary magnet for this one situation. You want to changing the flux. So we're using soft iron core. Soft iron core, when they magnetize and demagnetize, they're very fast. So when they're very fast, that means they no need to support so many heat. Okay, so soft iron, they require very small amount of energy to magnetize. So this one is a way how to reduce energy loss. Okay, so when the question just asks you how to reduce energy loss, you can just say the hysteresis. Okay, then the reason is what? Reason is we use the soft iron core. Then after that, reduce the energy waste when magnetized. Okay, hysteresis. This one is one of the words to explain magnetize and demagnetize. So some question will ask what core you want to use. Then you choose soft iron core. So what's the reason? Soft iron core, the reason is easy to magnetize and demagnetize. So this one is how we're going to choose the core. Okay, they can give you the steel, aluminium or others. So better for the transformer, we must using soft iron core. Okay, the reason always easy to magnetize and demagnetize. Okay, then we go to the last one, leakage of the magnetic flux. So remember when it just changing magnetic flux, surrounding there will leakage. Okay, you see the diagram. I show the diagram first. Okay, this one is the first diagram for the textbook. Okay, you can see the blue color. Blue color, that one is a leakage. So that means when the primary, they want to send to secondary, okay, between the sending, there will leakage. They will lose some of the heat energy. So from here, they say the magnetic flux produced by the primary current is not fully linked to the secondary because you lost at the halfway, you lost already. So how we go to reduce this energy loss? The secondary coil is wound on the primary coil so that all the magnetic flux produced by the primary that will pass through the secondary. So that means they don't want to separate primary and secondary. They want these two coils joined together. When they just join together, that means they no need to far distance to transfer the magnetic flux. Okay, so they can reduce the energy loss. Okay, now I let you to see how they create the transformer. Okay, this one shape. This one we call shell type of the transformer. Can you see the center? They got one of the iron core. After that, they're winding the wire. Okay, primary and secondary, they put together. Then when they're just changing the magnetic flux, they want to change the induced current, they are near. Okay, when it's just near to sand, that means they reduce the leakage. Okay, we also can see this one is a structure. Okay, the primary they join to the battery, okay, or to the power supply. Then the secondary at the bottom, they join with the electrical appliances. So that means two also winding at the center. So this one is one of the way how to reduce the energy loss. Okay, to overcome the problem of the leakage. So that means we got four of the factor to make the transformer to lose the energy. The first one is a resistance. Number two is a eddy current. Okay, number three is about the number three is what? Okay, we're talking number four first. Number four is a leakage. Then number three is I also forget number three is what. Okay, anybody can tell me number three is what? Okay, this one is a leakage. So number three, number one is resistance. Number two is a eddy current. Number three is a the hysteresis. Hysteresis, that means magnetize and demagnetize. So we got four of the way how to transformer lost the energy. Okay, we also need to think about how to overcome the problem. Resistance, so we're using thicker wire. Okay, number two, if you say about the eddy current, we're using laminate. Okay, laminated iron core to reduce the eddy current. Okay, number three is a hysteresis. We're using soft iron core. So you can together, we're using laminate soft iron core. Okay, laminate is eddy current, soft iron core is a hysteresis. And the last one is a leakage. So you must mention your primary coil must bond together with the secondary coil, okay, at the center. So this one can reduce the leakage of the heat energy. Okay, eddy current. Okay, eddy current is lost energy from the transformer because it produces a heat, is it? But eddy current also got another function. Okay, you can see from here. A high frequency alternating current. Okay, you can see the circuit now, they draw alternating current. In the coil, they're producing the magnetic field that change the high frequency. So that means the alternating current later, when it just move, they produce changing magnetic flux. So from here, you can see they got coil. Okay, when the flux just go, that means they're same like the transformer, changing magnetic flux. Means this situation, they also will produce a eddy current. But this one eddy current got function because they want to heat up. Just now the transformer, they don't want to heat up. They just want to produce an induced current. So from here, the eddy current for the cooking, that's one of the advantages. So you can see example for the cooking, they're using the eddy current. This magnetic field that induce the eddy current at the base of the pan. Okay, so you can see the shape. They're just like the coin shape. So that means when the alternating current just go, they can change in the magnetic flux, then they produce the eddy current. So this one eddy current that will heat up the base of the pan. Okay, so from here, this one is a induction cooker. Okay, they're using the concept for eddy current, produce a heat. After that, they can cook faster. Okay, so this one is an application for the eddy current. Okay, let's see the uses of transformer in our daily life. Transformer, remember we got two types, step up and step down. Okay, now you see the step down. Step down, that means I want to reduce the output voltage. Example for your notebook computer charger. Okay, you want to reduce the volt when you want to charge. Okay, photocopy machine, welding machine, this one they're using the low voltage. Okay, so example for the step up. Okay, microwave oven. Example. Okay, this one is a defibrillator. Defibrillator, this one they use by the hospital. Okay, after that we got X-ray machine. This one only example. They want to using the high voltage. So we're using step up transformer. Okay, so this one's the uses for the transformer in our daily life lah. We can separate only by two types, step up and step down. Okay, so this one is the last part for transformer. Okay, and one more is a electrical energy transmission and also distribution system. Okay, this one is how we get the electricity, okay, from the power station. So first round, you must start from the power station. how the electricity go to send until to your house. So first round, you see the generation of the electricity. The first one, red color one, that one is a step up transformer. When starting, when you see got power station, then the joint transformer, you must remember that transformer sure step up. Okay, you can see they're using 20 kilovolt. Okay, 20 kilovolt. After that, they step up until 27 kilovolt. Okay, first round they want to step up. Okay, later I will explain for you why the first round they want to step up. Okay, after step up, they will send by long distance transmission electricity. There's a long distance until to the main receiving for the substation. Okay, from the substation, all will start step down. Okay, they go to the heavy industry, lighter industry, then go to the school, go to the office until go to your house. So they will keep step down until the last one, until go to the consumer using. Okay, so remember for the transmission, the whole system, only power station, when they want to send about the transmission cable, they're using step up. Then after that, the rest, they're using step down. Okay, now we go through why like this. Okay, why got step up only one, then the rest step down. Okay, we go to the next. Okay, main receiving, this one is the first one, they step down already. After that, they go to the distribution. They want to give to the heavy industry, light industry, and the last one, they go through the consumer. Okay, so from here, we go to the diagram. We go and see the explanation why the first one is step up. Okay, step up transformer are used to increase the voltage. This one everybody know lah. Step up transformer, they want to increase the voltage in the power cable so that the current in the power cable becomes more. So you can see the first formula. P equal VI. This one we learned already. Okay, why they increase the voltage? You see, power constant. Okay, we never provide any power already. The power fixed. So the voltage, I make the voltage become high. Okay, you're using step up transformer. So automatic, your current will drop. Agree? Okay, because the power is constant. So why I need the current drop? Okay, when they send about the transmission cable, okay, the reason is like this. This reduce the loss of the electrical energy from the power cable. Because when they just send, the cable is very, very long. Okay, until you go to receive. Okay, so that means when it's just long cable, then you understood lah. Long cable, the length should be longer. Okay, length longer, resistance must very, very high. So when the resistance become very high, energy will lose. Okay, the power also lost. So from this, we create one of the formula only using for power loss. Okay, only using for this one transmission cable. So the formula is a power loss equal I square R. Okay, don't misunderstand. This one power loss and this one P equal VI is a different. P equal VI is a power input. Power loss is when you just send, the power will lose during the cable. During the wrong cable, they send, the power will lose. So from here, we need to reduce. Either you reduce the I, either you reduce the R. Then you can reduce the power loss. Is it? The problem is we never go to reduce the resistance. Why we cannot reduce resistance? Okay, if you reduce resistance, you either make the line become shorter. Okay, but the cable already long. How to make shorter? Cannot. So we think another way. We're using thicker wire. If you're using the thicker wire, that means the resistance can be dropped, is it? But you need to think long cable, thicker wire some more, means high cost. Okay, the cost is very high. So we cannot support it. So resistance will already cancel. We don't think about resistance. So what we need to do, we reduce the current. Okay, reduce the current to send to the cable. How to reduce the current sent to the cable? We increase the voltage, increase the starting voltage. From the power supply, we're using transformer to increase the voltage. When I just increase the voltage, understood the current pass through the cable, you drop. Okay, current pass through cable will drop. So that means when the I square, when the I just drop, then the power loss will be reduced. Okay, so this one is a why only power station they're using step up transformer, because they want to reduce power loss. Okay, this one is a reason. So we go to explain. Current drop, power loss will decrease. So from here, during the distribution of the electrical energy, step down transformer are used to reduce the voltage in the power cable in the stages to a suitable value of the industrial and also residential consumer. So this one is talking about after power station. Already sent long cable until you go to the main for your housing area, for your local area power station. And that one you can step down already. But when starting power station, you must go to increase the voltage. Okay, important, they don't want to make the power loss. Okay, until sent to your house, the power loss so much. Okay, so this one is a reason when the question just asked why only using power station, they're using using the step up transformer. Okay, so from here we go to see the example for the diagram. Okay, you see the video part. So this one is the power stations. Okay, when they start to send, you can see this one transformer, there's a step up. Okay, this one is the output. You can see the number of turn for the output is more. More number of turn means voltage is higher. Okay, now they go to step up the voltage. Step up voltage means the current is become lower. So you can see the cable. You see the cable so long when you want to send. Okay, so the cable so long means they want to reduce. Okay, reduce the resistance. Okay, reduce resistance also no use. You using the thick wire, very expensive. So that's why they go to make the current become smaller. So you can see when they just send until they want to reduce, until this part. You can see until consumer, they also make the transformer become step down already. Okay, from the heavy industry, okay, I play back, you see the heavy industry. This one is a heavy industry. Until heavy industry, you can see the step down. Okay, then the heavy industry also pass through the cable until go to consumer. Okay, consumer until go your house. Always using the step down transformer. Only the first round, when you see power station, that one sure is a step up. Okay, so we see the explanation. Okay, step up transformer only used when they start from the power station. Okay, from the power stations. So number 2 is after that all, they will use all step down transformer then to reduce the voltage. Okay, so that means just only first round. When they just send, go through the longer wire. Okay, before they want to send to the sub power station. Okay, they will stop down already. Okay, they will reduce already. So from here, the rest they will using step down transformer. Okay, so from here, the transformer for the energy loss and also transmission we finish. So what we need to do, now you're ready your calculator. Okay, prepare your calculator. So we need to start to do the calculation for transformer. Okay, first one, you see the figure. They show about transformer connected to an electrical appliances. Okay, the power supply 240 volt. Sorry, power supply, yeah, they show by V1. Okay, the voltage is a 240 volt. Switch S is turned on. Then the secondary circuit is 0.25 ampere. Okay, state the type of the transformer used. Okay, so from here, we go to step up transformer first. Everybody know why step up? Because you see the V1 is 240. V2 is how many? 3,200. So I know this one sure is a step up transformer. Okay, we need to show about info. Okay, the info from the question. Primary 240 volt, secondary 3,200 volt. Okay, primary current. Primary current is where? Okay, primary current is 4 ampere. Where I get it? Wait, this one is a secondary, is a 0.25. Okay, this one, 4 ampere is here. You can see the 4 ampere from the diagram. This one is a primary. So this one is a secondary. They already write here 0.25. Then after that, they want to find is a efficiency. Okay, they want to find efficiency. So from here, I show you some info first. Okay, remember efficiency, the formula is a power secondary over power primary, means power output over power input, multiply 100%. Okay, now I want to find what is the efficiency. Okay, so I need your help to give me the answer. Okay, for example 1. Okay, so student, please write the answer here. Then I know you understand or not understand about this question. Okay, we just wait the student. Prepare your calculator and type the question. Type the calculation now to give me the answer. Okay, how many is here? I've got 29 students watching only. My class got 34 students, but I've got 29 students watching. Okay, how many can give the answer? Yiru can give or not? Rayan here or not? Okay, Jaya give me 83.33. Unit is what? Unit is percentage. So from here, we just put, okay, PS also can write as a VSIS. VSIS also can. Then over VPIP multiply 100%. So your answer sure less than 100%. If you find your answer more than 100%, that means your calculation got problem already. Okay, yeah, Ling Han give me percent already. Okay, so the answer is 83.33%. So this one is a final answer. Okay, Khatija also correct. Okay, then we go to second question. Okay, second question is a 5,000 watt, a 5,000 watt of the power is transmitted. So understood, this one is P input. Okay, through the cable of the resistance. Okay, they provide resistance 5 ohm. What is the power loss in the cable if the current is transmitted at 1,250 volt? So this one talking power loss. Just now we learned about power loss. Okay, we write the info first. Power 500 watt transmit. This one is a power input. So the resistance for the cable is a 5 ohm. Okay, then the voltage. The voltage when it just transmitted, there's a 1250 volt. Okay, then after that power loss. Power loss don't know. Okay, so from here you need to find the power loss. You must have current. Agree or not? No current, we cannot do anything. So from here we go to check. Okay, so power loss, the formula is I squared R. Okay, we know the R, but we do know the I. So how to find the I? Okay, the I normally we find from the input, power input. Power input formula, P equal VI. So you find for me what's the current now first. Okay, what is the current? Okay, so from here we find the current, then later we find the power loss. So you tell me the current first. Okay, you get the current. Okay, some student you can start to do the calculation for current. Then some student you can straightforward get the current to do the calculation for power loss. Okay, so you can straightforward to type for me current is how many, power loss is how many. Okay, we're going to wait the student do the calculations. Okay, understand the question and write the info. That one is important for you. Okay, many of students never do this one. So you miss some of the information. That means your calculation wrong already. So if you list out, that means when you check, you're also easy to check back. Okay, which part you do wrong calculations. Okay, because sometimes we press calculator very fast. We cannot see. So that one is one of the problem, careless mistake. Okay, any student can find for me what's the current now? Okay, what's the current? No student to answer. Yiru can answer or not? Current? Okay, we're going to wait. Many students also never reply. That means I don't know you got attend or never attend. Okay. Charan, are you here? Charan, long time already. Never see. Okay. Some more? Okay, 4 ampere. You do give me 4 ampere. Okay, the rest you go to calculate power loss. Okay, so from here I'm going to show the calculation how to get the current. So the current is 4 ampere, correct? Okay, Alicia also correct. So the next student, give me the power loss. Power loss. Okay, Danish also get 4 ampere. Yeah, correct. Then Trish also 4 ampere. Esther faster to count the power loss. Power loss. Okay, Khadija get it. Power loss is a 80 watt. Okay, we go to show. Is it 80 watt? Okay, power loss, we're using the formula. So the current just now is a 4 square multiply the 5. So the 1000 is a 80 watt already lost. Okay, so that means I'm using 5000. Then I lost how many? 80 watt. Okay lah, still okay, is it? Oh, that means you just lost not more than quarter or so. Okay, so this one we call it how to find the power loss. Okay, I think the student also correct from here. They get 80. Okay, yeah. Okay, then Sabrina also here. Okay, so we continue to the next question. Okay, number 3. Okay, number 3 about the transformer again. So why the soft iron is used? Remember this one question. So I asked so many times already. I also explained so many times why we using soft iron core. Okay, for the transformer. So the answer is soft iron core is easy to magnetize and demagnetize. Okay, so from here, please remember when the question just asked like this, so we need to answer easy for magnetize and demagnetize. Okay, or you can see increase the strength of the magnetic field, and the last one reduce energy loss. Okay, the last one, you only cannot think. I mean, you cannot think anything already. No, and don't have any comment. So you just write the last one. Okay, I didn't encourage you write the last one. Last one is you no choice already. You don't know how to write. Then you just write the last one. Okay, so normally the soft iron core is the first one. Easy for magnetize and demagnetize. Okay, then we see the info from the question. Okay, diagram they got show input 240 volt. So I put 240 volt. Then the output is a 6 volt. Then the output you put 6 volt. Okay, number of turn. Number of turn, the question already told you. Primary coil is how many? 2000. Okay, but the secondary coil, we do know. Okay, so the student, you need to count for me number of turn for the secondary coil. Okay, I give you the formula. Vs over Vp equal Ns over Np. I want to find Ns. Okay, secondary number of turns. Okay, secondary number of turns. Okay, we just wait the student. Why the Esther give me 80 for what? Okay, Khadija give me 50 tons already. Okay, Alicia also give 50 tons. Esther also. Okay, we go to check. Okay, we put in all the info. Then final answer, yeah, 50 tons. Okay, 50 tons is correct. Okay, I think no problem lah. The student already understand about the how to apply this formula. Okay, Linhan also correct. Okay, we go example 4. Okay, 4 already. So this is a symbol for transformer. Okay, efficiency of the component. Okay, now they told you efficiency. Efficiency is a 80%. You need to calculate the power you need to calculate the input current when the output power is a 65 watt. Okay, output 65. Okay, then the input don't know. Okay, input don't know the power and also don't know the current. So from here, you need to calculate the input current. So from here, info I just write first. Efficiency 80%. Power for the secondary 65 watt. Okay, primary voltage 240 volt. Okay, current for the primary do know. Okay, so from here, please do the calculations to find out power input first. You find the power input, then you can find what is the current input. Okay, so I show you the info for this one first. Okay, percentage efficiency equal power secondary over power primary, then 100%. You find for me what is the PB first, power primary. Okay, I want the PB first. You give me the PB, after that you find current for primary. Okay, so from here the student, you also need to start the calculation. You give me the power input is how many first. Okay, so from here efficiency got already, there's a 80. So you give me the answer for the power primary, or you say power input. Okay, so Jaya give me 52 watts. Okay, 52 watts. We go to check, is it 52 watts or not? Okay, Lisa also same. Okay, we go to check. Okay, 80% we put here. 65 over PB. So we find the PB first. Oh, PB is 81.25. Why you give me the answer 52? Is it a 52? I don't know. I gotta check first because I do the calculations. Okay, so from here we get 80%. Oh, sorry, no more. When I just change to here, 80% becomes 0.8. Then after that, 65 over 0.8. Your answer is it got problem? Why 52 watts? 52 watt means your PB already less than the power output. How come like this? Your power input must more than the power output. Please do again your calculations. Okay, a little bit problem already, your calculations. Okay, so the answer must be 81.25 watts. To the balik. Okay, so the Esther give me the final answer 0.3385. Okay, so we're going to check. Okay, make sure your Esther using the power input same like my answer. Don't using Jaya one. Jaya one already do the balik. Okay, so from here we go to check the current. Okay, if you get the PB, so at 81.25, so we put VP equal IP. So VP is how many? 240. Okay, final IP is 0.34. Yeah, correct. Correct. Ling Han and also Esther also correct. 0.34 ampere. Okay, you can put 4 decimal point. Okay, so this one question a little bit more method you need to solve. Okay, important you understand. If you understand already, actually calculation is no problem for yours. Okay, don't Jaya, be careful, don't be terbalik the formula. Okay, then we go to the question number 5. Okay, question number 5, they just want you compare. If the voltage, just now I told you power station must step up, is it? So now we need to compare. If we never step up, we're using low voltage, what happened? Okay, the first round, electric power transmitted from the power station. Transmission cable is total resistance 50 ohm. Okay, they give you the resistance, the 50 ohm. If the power station generate 220 kilowatt of the power, okay, so this one is a 220 kilowatt power input. Calculate the power loss in the cable if the voltage transmission is 11 kilovolt. You see, be careful, got kilo. So we show the info. Resistance 50 ohm. Okay, then the power input 220 kilowatt. Okay, sorry, this one is power loss. Is it? No. Okay, 240, 240 is, wait, 220 is it? Do some wrong in 4. Okay, I do the calculation wrong already. Okay, I go to change first, power loss. They never tell you power loss, is it? Okay, so I go to cancel this one. 240 is what I also don't know. Okay, I go to turn back. Okay, this one. So from here, you need to calculate for the power loss. Okay, you want to calculate for power loss. So that means you need to what? You need to find the current. Is it? Every time they never provide the current, but they told you the voltage is a 11 kilovolt lah. So that means they make the transformer when starting, they just increase become 11 kilovolt. Okay, so you can see from here power, voltage, then resistance, current don't have. So we find the current first. Same thing, we find the current. P equal VI, so we're using the formula. 220 kilo. So 11 also kilo. Then we find 20 ampere. Okay, this one's a 20 ampere. So you help me to find, is it correct or not? Is it 20 ampere or not? So after that, you give me the answer for power loss. Okay, if I just using 11 kilovolt of the voltage. Okay, transmit the cable, okay, until to the consumer. So that means the voltage I never increase lah. Later I got another calculation. We're using high voltage. This one voltage only 11K. So now you show the calculation for me. Is it the answer for the power loss, high or low first? Okay, we want to check because we just only got 20 ampere. Okay, for the student, you can start now to do the calculations. Okay, 20 ampere. Current is 20 ampere. So you find for me power loss. Okay, power loss, you just take your 20 ampere, you go to square. Okay, you go to square. After that, you multiply your resistor. Okay, we check power loss, you get how many? Formula power loss. Okay, this one, So we're going to check power loss. If you're using 11 kilovolt, you lost how many? Okay, 20 kilovolt, 20 kilowatt. Okay, so from here, the answer for Zhihui, 20 kilo. So we go to check. Okay, I put in. So I will lost 20K. Okay, I provide 220K. I lost 20K already, Okay, so means you lost so much already if you lost 20K. Okay, now we continue to do the same calculation, but I go to increase the voltage. I'm using the transformer to increase. So you see what happened. Okay, I make it become 400K. Okay, I'm using a transformer to step up 11K. I make it become 400K. Now you tell me power loss is how many? Okay, the same process. Okay, again, this one I copy wrong already. Just cancel this one. Okay, power loss. So from here, we just want to find current. Okay, we still need to find the current. So the current P equal VI. So we find the current. Current only 0.55 ampere. Okay, so just now 11 kilovolt, they already got 20 ampere. 20 ampere is high already. So this one, they step up the transformer, make the voltage become 400K. So the current transmitted become less, 0.55 ampere only. So the last one, they ask you, power loss is how many? Okay, so I want you to see the differences. Okay, if they're using the high voltage and low voltage when they just transmit from the power stations. Okay, so what's your answer if I'm using the 400K? Okay, just now actually you can see the answer already because I fast go to changes, is it? So what's your answer if I'm using 400K for your voltage? Okay, we get the answer from the student. Okay, anybody? Okay, just the calculation is the same. I show again the power loss formula. Okay, power loss equal I squared R. Okay, 15.125. You see, is it very small compared just now? Only 15.125 kilowatts. Just now is how many? 200, is it? 2 or 220, I think. Just now is 20 kilowatt. So this one is a 15.125 kilowatts. Kilo hilang eh. Kilo we got kilo Is it watt or kilowatt? I think got watt only, is it? Okay, I go to square. No kilo. Kilo hilang already. Okay, we go to square. 0.55 square. Multiply 50. No kilo. Ayo, my kilo. Please, no kilo. If kilo, no more already. So this one is no kilowatt. Only watt. So I only lost how many? I only lost 15.125 watts. You see, very less already, is it? Compare just now. Okay, we're going to do the comparison. Okay, just now is 20 kilowatt loss. Okay, then this one is, change back. So many wrong. Okay, so this one is only 15.125 watts. So this one is a difference lah. Why we get the big differences. Okay, the voltage just now is 11K. Now I increase the voltage become 400K. So that means I can reduce the power loss. Okay, I no need to adjust any power. Okay, I no need provide more of the power input. No, power input still the same. Just I using step up transformer. Then I can save the energy already. Okay, so this one is a reason why the first round they're using step up transformer. Okay, so from here they ask you what is your conclusion based on the answer just now. So the conclusion is power loss in the cable is greatly reduced by transmitting power at the high voltage. Okay, so this one is a conclusion we can do it lah for the just now two calculation. One using 11K, another one using 400K. So the power loss is a big differences. Okay, so from here, actually the lesson is very short because later you got extra class some more. Okay, I already upload the exercise for you. Hopefully you are finished because later the extra class, we need to explain, discuss about the transformer question. You got objective, you got structure also. So today task, actually that's just for attendance. So I already upload there. You just go to the Google form. Then you need to type the lesson code for your attendance. Today lesson code. Okay, help me to type here. Resistant, capital letter, resistant, RESISTANCE, underscore 88, number 88. Okay, help me to type here. Okay. Anybody fast one? You help me to type resistant, capital letter. Resistant. Then you put underscore. Then you put the number 88. Okay? Capital letter. All in capital letter. Okay? I go to pin. So this one is a today lesson code. Resistant. Then underscore 88. Yeah, correct, Lisa. Okay? So that means you just go to type at there. Don't copy paste. So I want to know actually you got attend my class or never attend my class. Okay, yeah, Sharon, correct. Okay, so from here our lesson just until this part. So I will see you on the 2:30, is it? Later 2:30. Okay, I will see you. I will already give you the a link. I will using Google Meet. Okay, Google Meet. Then I will send you the link 5 minutes before lah. Okay, you refer the Telegram. Okay, so our lesson until this part, then we'll go finish. Thank you for your watching. For the next lesson, there should be go to new topic. Okay, there's an electronic. Okay, bye every student. So please go to attend your write your attendance. Attendance very important. Okay, bye everyone.